So the next one is the array and matrix. We will take a look at what is array. This is very specific to almost all the programming language. Those of you have worked on C language, C++, Java, you must be knowing what is arrays and matrix. It is a data structure. Okay, arrays and matrix is also a data structure. Using array, we can store the collection of items. Typically, you can store the same data type. You cannot mix different data type in a contiguous fashion. In a contiguous fashion, you can store the data in a memory. Okay, for example, I'll create an array here. Okay, so for example, ARR1 is equivalent to, let's say I'm going to use some 1, 2, 3, 4, 5. And next one is, here we have something called NumPy package, using which also we can create an array. Another package is something like, we have something like import array. Okay, we can use, from array package, import array. I'll explain you, wait. Okay, I'll explain you what this one is. Just give me a second. And we have something else called, okay, and here I just say array of 1, 2, 3, 4, 5. Yeah, or 1, and if I do this, it gives me array argument as a 1 Unicode character list. Okay, in this case, yes, Praveen, 1 second. I will call you back. Okay, 1 second here. I'll just come back. So you can create an array using two different approaches. One is there is a package called array. Okay, that is available as part of Python. When you install Anaconda Python, it will install these packages by default. You don't have to install, these packages explicitly. So in this package array, there is a method called array. Okay, I want to explicitly, I should tell very clearly, from this package, import the array method. So here the array, when you use the array function, you need to define the data type. So whether it is an integer data type or is that a float data type. Okay, and in this case, array, we have mentioned I and 1, 2. Okay, sorry, here I need to put the square bracket. So okay, here array is array got created. The ARR1 is array type. For example, if you type ARR1 and if you press enter, so array. This is one way of creating array. What is that? A question from Sri, and what she is asking is, how can I create a decimal value? Yeah, that is your float type, F, right? And you can use float type, and here it will say array. Okay, here I just say it's a float type. Look here, though the values are integer here, since we have declared it as a float type, yeah, it's getting recorded. Don't worry. Okay, it's being recorded. Okay, so it puts the .0. With that, you can understand it is a float data. This array is a float type. This array is a integer type. Okay, likewise, you can create the arrays using array package. And apart from this, we have something else called NumPy package. There is a package called NumPy, like array. Okay, import NumPy as NP. What is as? This is an alias. Okay, so this is an alias. So this is the commonly used alias. For example, it's a nickname. Some people have a bigger name, but at home they use a nickname for the sake of simplicity, right? Similarly, what we do is, whenever you import any package, along with that, we use the keyword called as. This is a keyword. Here you need to specify whatever the name that you want to use it, you can use it. But this is the commonly used alias for the NumPy, NP. So now I just selected this and I hit the run button. Now this package got imported. So now we'll see how we can create an array using the NumPy package. Okay. So for example, I want to create a one-dimensional array. In this case, let's say array underscore 1D is equal to np dot array. So you have an array function that is available as part of NumPy. Instead of typing NumPy, the bigger name, we use this short name, np alias np dot array. And here you can say 1, 2, 3, 4. 1, 2, 3, 4. Okay, we can say, and I'm going to type array 1D. Okay, and I'm going to use something called print function. And again, I'm going to use another print function to display the dimension. Okay, and in this case, array, my array name is array 1D dot ndim. It gives me the dimension. Okay, it's a one-dimensional array. Array is multi-dimensional. We can have multi-dimensional array with array, but the data type should be same for all the values. Whatever you use it in array, it should be same data type. It should not have a mix of a different data type. Okay, array is a multi-dimensional. It can hold the same type of the data in it. Okay, and the data will get stored in sequential. For example, so here in this case 1, 2, 3, same as our list, you remember. So these are the values. It will get stored in array, in sequentially. Okay, contiguously it will store the value. The index value for this one is, it will start from 0, 1, 2, 3. Using the index value, you can access a specific value from an array. For example, here if you want to array underscore 1D of 1, if you specify, so display the value 2 that is stored in the the index location 1. Okay, so this is how you can, same as your list. Okay, you can access the values using index in the case of array also. So np dot array is the one widely used when compared to the array package. The NumPy package is used. In the NumPy package, you use an array method. Using this method, you can create an array. So this is a one-dimensional array. Okay, yeah, yes, Shri, I'll come back. Give me a second. I'll just show you one by one. If I jump here and there, you will not be able to understand. What I'll do is I'm going to create a two-dimensional array. Our question is how to create a two-dimensional array. Okay. So here I'm going to use another list value 3, 4. And for example, here I'm going to say 5, 6. And in this case, so here I just say array 2D dot ndim. So there is something called ndim function that gives you the dimensional. Okay, array. Okay. In this case, you need to put one more thing. Okay, you need to put one more square bracket. So it gives me two-dimensional array. Okay, two-dimensional. But whereas if you see here, the last one, it's a one-dimensional array. This is a two-dimensional array. Okay, this is a two-dimensional. Next, we'll try the three-dimensional array. In this case, I'm going to say something like 1, 2, 3, and 4. Let's say, here I just say 4, 5, 6, and I'm going to close it. Sorry, what is this? Put it everything in a square bracket. So this is one dimension, and 1, 2, and 1 second here. 1, 2, 3, 4, 5, 6. Okay, and okay, this I'm going to remove it. In the next line, I just try the other one. So here I'm going to put 7, 8, 9, 10, 11, 12. So you need to wrap this by, you need to end this by the closed parenthesis. And let us check if I keep this one. No, it is not matching this one. There is something wrong here. And here, this one ends with this one, and this one ends with this one. Okay, in this case, we don't, yeah, we need to have one more thing here, right? Yes, we need to have one more for this square bracket, the first square bracket. We need to have a corresponding square bracket here. Look here, when you keep the cursor, this one, getting displayed in green color, right? That means for this square bracket, there is a matching square bracket. For this open square bracket, you need to have the corresponding closing thing. That is what we can see that. Now, if I click on this one, which one? Open parenthesis. Sorry, this parenthesis, when I click on it, there is a matching here. And if I click on it now, it gives me 3-dimensional here. We have 3 dimensions here, okay? So the ndim it's kind of a function. It helps us to find out whether the given array is 2-dimensional or single dimension or 3-dimension or 4-dimension. Okay. So now we will print the array of 3D. Let's see how it looks like. Okay. It's a case sensitive. Since D is the capital letter, it is not displaying it because here, yes. So since D is a capital letter, you need to use the same, case. Okay, array 3D is, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is your 3-dimensional array. Okay. What is that? Your doubt? Why don't you unmute and talk now? Why don't you? I did not get your question. Okay. Okay, here I mentioned about 1, 2, 3. Okay. So this one, the dimension will give you the depth or layers. Okay. So in this case, this is a first layer of your matrix. And then this is your second layer or matrix in this case. Okay. This is, or we can say first row of the first layer and second row of the second layer. Okay. So here for each column, sorry, each row, we have 3 values, right? For each row, we have 3 columns, 1, 2, 3. 3 columns for the first row of the first layer, right? And what I will do is, for the sake of your understanding, I'll just put it in this way. Okay, this is one thing, and this is here, right? In this case, each row we have 3 columns or 3 values are there. Okay, but here in this case, each row we have 2 columns are there. So hence it is a 2-dimensional array. Okay. In this case, in the square bracket, we have only one square bracket. Hence, see, we have only one row, right? Hence it is 1-dimensional. But in this case, right, we have multiple square brackets, right? So, and also each column we have, each row we have 2 values. Hence it is called 2-dimensional. In this case, it's a 3-dimensional. Okay, 3-dimensional. This 3-dimensional tells us the depth or the levels of the nested lists or arrays within the main structure, right? That's how we need to understand it. Okay. The dimensions. Now you understood what is array is all about. Array is all right. You can with array function also can create the basic arrays, and the NP array. This is the one because if you create any array with as per your question, the NumPy function is pretty faster in general to perform any arithmetic calculation. And the NumPy package is pretty faster than your array and other packages. Okay, that is the reason why I started explaining this one. Which one? The NumPy, using NumPy how to create arrays and all. Okay. Yeah, accessing the values, it's same. Okay, now her question is, how can I access this specific values? If I want to display 5, how can I do that? Sir, here you need to use array underscore 3D of, you have, for example, I put, 1 here, and here I put 1 here. Like in nested list, how do we find out, right? So in this case, in the, what is that, 10, 11, 12. So 10, 11, 12. So 1 comma 1 gives me this one. Okay, for example, if I give 1 comma 0, what is going to happen? And okay, 1 comma 0, or let's say 0 0, right? 0 0. If I select this, so 1 2 3. So the first value, for the first row, the index value is 0, and the second row, the index value. Okay, I will just show you that, don't worry. We will give 1 here. So 4 5 6. You need to specify the value here. For example, if you want to access, so this one is considered as the 0th index. Okay, 0th index. In the 0th index, first value, what is there, right? So in the, this is the one it shows here. Okay, and if you access this value, okay, your point is you want to access only 5. Okay, you need to use another one. We will see. Yes, this is how you need to use it. If you want to slice only 5, what you need to do is you need to tell, hey, go to the first row. Sorry, this is the index value 0. This one is an index value 0. 1 second. For this, yeah, for this, look here, it ends here. And okay, here. See this one, right? These two are there in your 0th index. In the 0th index, go to the first row. In the first row, first index, okay? And in the, sorry, in the 0th row, sorry, the 0th index. The 0th index is pointing this one. Okay, and these two are pointed in 0th index. But in the 0th index, in the list, how did we do that? How many of you remember? In the nested list, I explained, right? The same thing here. In the 0th index, go to the second list. Second list is your 1, right? 1. The index value for the 1. The second value is 1 here. Okay, this is how you can slice the array here. The nested list, explained you this one. The same idea is applicable here also. Okay, next one is matrix. How do we, okay, our question is, can I multiply the values of arrays? Okay, array 2D. Okay, here I am going to, for the sake of continuation, I just take this one, array of 2D. Is this what you're asking, Swarna? Okay, array of 2D, array of 2D. Can I multiply? Yes, you can directly multiply the values, array of 2D into array of 2D. But is it possible to do the same thing with the list? That is not possible. For example, L1 is equivalent to 1, 2, 3. L2 is another list. Here also I'm going to put 1, 2, 3. And if I put L1 into L2, it will not get multiplied. Look here, you cannot multiply sequence by non-int of type list. One list values you cannot multiply with another list, though the number of values are same here. That is not possible. The advantage of array is you can perform the direct arithmetic operation. The same array, if I multiply it with itself, so 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9. That is possible with array. Okay, multiplication, division, everything you can do it. Yeah, you can multiply. Yeah, you want to multiply. So the array of array 2D, We're multiplying an array with the same array. And if I do this with 3, is it possible to do that? Yes, 3, 6. Okay. What is size? Oh, okay. You want to say know the size, right? There is something called size here, 2D dot size. It gives you how many number of elements are there in an array. Okay. So you have ndim function and size function. With that, you can understand, what is the dimension of this array, which you defined it. Now, how many number of elements are there in an array? You can see that using size. There is another function, 1 second, array of array underscore 2D dot, let me press tab. It is not displaying it here. All, okay, argmax. Likewise, lot of functions are there. If you want to find out the maximum value, you can use max function and argmax, argmin. That and all, we'll see it later. And yeah, if you want to do sum, right, you can use sum also here. If you want to do list of this one, no, here the list will not work. Or else you can use the sum function directly on top of it. I think so. You can use this one. You want to sum all the value, right? Yes. So, it gets summed, vertically. 8 plus 1 is 9, 10, 12. So sum is possible. So likewise, you can explore all the functions, but remember that all the functions, you're not going to use it. Okay, so important functions, if you know, that is enough. Like the size function, that is very much important. Size, ndim, and in fact, I was looking for another function which I forgot it. That one we use it more frequently. As type and copy data dot dumps item max min. You can find out the average n bytes. Rival round shape. Shape, correct. Shape is also the function which we use it more frequently. In this case, with shape, you can find out how many rows are there, how many columns are there. Okay. And similarly, in the array 3D, I think this is what you are asking it, right? Swarna, sorry, the Sri shape. Yes, I will share all the, see, what the plan is, we will include everything in tonight, in your night time. Okay, so for me, it is daytime here. So your night time, what we will do is we'll ask our people to upload all the script on our website so that we can look here. This tells me the number of dimensions, how many number of dimensions there in array. This gives me, here, so 2, 2, 3. Here we have, this is nothing but your 3 dimension, but here you have how many? 2 rows, right? So look here, you have 2 by 2. And sorry, 3 columns, and you have 2 by 2 rows are there. 2 rows, 3 columns. Here 2 rows, 2 rows are there. So 2 rows are there, right? So here this is in this case we have 2 rows, and in this case we have 2 rows, and each row we have 3 columns are there. That is what it tells you. Okay. So the ndim, shape function, and size function also we'll be using it more frequently. And okay, can I with multiply array 2D with array 3D? Oh, okay, that's a very good question. This question is from Sri again. Array, because it's array 2D is your 2-dimensional array, right? Into array 3D. Will it work? It will not work. Operands could not be broadcast together with shapes 3, 2 and 3, 2, 2, 3. So here the array 2D is as we have seen, is the shape is 3, 2. 3 rows, 2 columns are there. But here, see, if you want to multiply the same array with another array, both arrays, the dimension should be same, the shape should be same. If you have 3, 2, and you have another array with 3, 2, that is possible. But if the two, arrays have different shapes, in that case, you cannot do the multiplication. This is a very good question. Okay. Can I, okay. That's what I answered already. Fine. Okay. This is the one you need to remember it. Okay. Because these two arrays having two different shapes in it, hence you cannot multiply them. Next one is the matrix. We have something called matrix. Matrix is a very popular one. I think almost all of you, except the non-IT student, right? So you must be familiar with this one. So how can I create a matrix? You can use NumPy package, the same as this one. For example, reading matrix. I just give some title for this one, markdown. So here I'm going to use the import, already imported it. Any of for the sake of demonstration, I'm just doing it. Here I'm going to say matrix np.array. Now the question is, what is the difference between matrix and array? Array is multidimensional. Matrix is just two-dimensional. You need to remember this is a very basic thing. You need to remember it. And here I just let's 1 comma 2 3 and the next one is 4 comma 5 comma 6. We need to put one more square bracket. Okay, the question is why we need the extra square bracket. So this is the syntax. Okay, I just tell you, just give me a second. Matrix. Here I put the additional one. Here I closed it. I know I should not have done that. And list integers must be integers also, not tuple. np.array. It should start with double square bracket. 1 comma 2 comma 3 4 5 6 7 8 9. Okay, what I will do is okay, I'll just do one thing. I'll just remove this one. 4 5 6, right? Or integers or slices, not tuple. Okay, here we did not use tuple, right? np.array. We have another thing is there. So what is this one? List integers must be integers or slices, not tuple. Using array also you can create it, the matrix. And we have np.matrix is also available. Okay, that is also available. And we will see that one also. How do we? It's a numpy array. np.array only I mentioned it, right? Correct. Yes, Swarna, I understood. Okay. You want to use matrix, right? Okay, yeah, that is possible. Okay, and so we have the function called matrix class. Okay, and that one also we can use it. Okay, your question is can you type? Okay, our question is type array 1D. Right? She wants to go back to the previous one before we jump in there. She wants to understand the array. See, numpy.nd array, n-dimensional array. So okay, if you check the data type, it is a np dot numpy dot, the array. And what we will do is, instead of array, I'm going to use it as a matrix here, okay? Matrix. In this case, I'm going to use, 1 second. See here, I made a mistake. Comma I did not put, right? So you should put comma here. Okay, that is the other problem. But okay, look here. So yeah, that is the problem. I did not put comma here. Okay, that is the problem. 7, 8, 9. And in this case, this is the, okay, let me do one thing. This is clear, right, Swarna? This tells you the data type here is n dimensional array. Okay, so matrix is also kind of an n-dimensional array only. Okay, now the question is, okay, matrix dot n-dim. I want to see that. It gives me 2-dimensional. Look here, matrix is a 2-dimensional one, and in this case, let me do one thing. We have another function, matrix itself available. Okay, this one kind of confusing when you use the array itself to define the matrix. What we'll do is we'll use matrix itself, matrix dot ndim. The same thing, if I use it, it gives me the 2-dimensional. In general, matrix just 2-dimensional only. Remember that. Array is multi. This is an interview question they'll ask you. And then we're going to create a matrix, two matrix. I just np dot matrix. What is that? You want to display that? 1 second, I'll just show you. np dot matrix. And here I'm going to say 2, 0, and comma here 1, 3. We will use this value, okay? And I want to print, yeah, so is it possible, like arrays, can I multiply the matrices directly? Yes, unlike list and tuple, when it comes to arrays and matrix, you can multiply, you can perform arithmetic operation directly with them, okay? First, field elements must be 2 or 3 tuples. Okay, here again I made the mistake. You need to use 2 square bracket. Okay, so first thing, right, you need to specify. This is the mistake when it comes to matrix, I often do that. Matrix, and first you need to specify the the square bracket. Inside the square bracket, you can specify the the values in terms of list. Look here. So mat A consists of 1, 2, 3, 4. And if I multiply this one with 1, 2, 3, 1 into 2 is, okay, let me mat A. If I print it, so mat B, if I print it. So in this case, the multiplication is 4, right? So here, 4, 6, we are getting, how did I get 4, 6, 10, 12? It is not element-wise multiplication. 4, it is not multiplying 1 into 2, 2 into 0, 3 into 1, 4. So you have something called matrix multiplication. So school time you studied, right? How do you multiply the matrix? So 1 into 2 is 2. And 2 into 1 is 2. Sorry. Here in this case, 1 into 2. Yeah, sorry. In this case, 1 into 2 is 2. Okay, here it should be something like 1, 2, 2, right? So 2, yeah. So 1 into 2 is 2. 2 into 1 is something like this, first row, first column. 1 into 2 is 2 plus 2 into 1 is 4. Matrix multiplication. School time, I think you forgot it, right? So this is the one. It goes the first row and first column. So 1 into 2. So this one into this one, 2 into 1 plus 2 into 1 is equivalent to 4. That is what we can see it here. Similarly, when it comes to the second one, so 1 into 0 is 0, 2 into 3 is 6. So 1 into 0 plus 2 into 3. 0 and 6. Don't tell me, I don't know matrix. I did not study. This is school time, 8th standard max. Next one is the second row. Same way. 3 into 2 plus 4 into 1. 6 plus 4 is 10. Next one is 4 into 0 plus 4 into 3. This one is 0 and 12. That's how this is called your matrix multiplication. There is a rule, right? This is a rule it uses the typical matrix multiplication. Okay. Okay. What is your question? See, this is the matrix multiplication, right? Oh, you want to know the element-wise multiplication. Element-wise? Why? So yeah, so you wanted to know how to perform. She wants to know, right? This is matrix multiplication is fine. Our question is, how do I perform element-wise multiplication? So we have something called np dot l. That's really a good question. There is something called multiply method. Np dot multiply, that is available in matrix. For example, if you want to perform element-wise multiplication, don't do the matrix multiplication. Multiply. Sorry, it's not multiple. Multiply. Sorry. Oh my God! I just interrupt the kernel. Okay, and yes, look here. In this case, what happened? So 1 comma 2. This one. Look here. This 1 and 2 got multiplied. This 2 and 0 got multiplied. This is called element-wise multiplication. Here, if you want to perform matrix multiplication, you can directly multiply the values, okay? Matrix A with matrix B. But the rule is make sure that both of them having the same size or shape, okay? If it is 2 comma 2, this one also 2 comma 2. Got it? So this is the one you need to make sure that. And yeah, multiply. This is your matrix multiplication. This is your element-wise multiplication. We want to simply perform the, each element from this matrix to other matrix directly. Don't do matrix multiplication. Directly do the element-wise multiplication. That kind of situation, you can use the np dot multiply function, using which you can do the multiplication, okay? And okay, what other things? Okay, how do I access the values from the matrix? Yeah, that is the same as the list. For example, in this case, mat A 0 will give you the first row. In the first row, I wanted to view the second element. Mat A 0. Okay, index 1 out of bounds for okay, sorry. Here, okay, here let's do one thing. 1 comma 2. 1 comma 2 is the first one. And in this case, let us do this way. So without this one itself, it gives me that one. And 0 colon mat A1. So second row it gives me, okay? In the second row, first value, it should give like this, but it gives me everything here. It is slightly different, accessing the values. Mat is 1 comma 2, 3 comma 4. Okay. In this case, 1 comma 0. Okay, 1 second. I'm just thinking about it. Okay. Only here we can use 0, we can display only the 4, right? So, okay, let me try the other way around. Mat A. Let me, if I try 1, comma 1, what is happening? Yeah, this is how we can do it. Mat A 0, comma 1, but it was, yeah, it is giving correctly now. So in the first row is this one, right? 2, 0. In the first row, second element 1. Directly you need to give. So don't give, one more square bracket, because this is not a nested one, right? Straightforward. 1, comma 1 and 0, comma 1. For example, you want to display 2. That is possible with this. Okay, and what are the other things you should be knowing it? So now you learned how to access the specific value in the matrix also, and how to perform element-wise multiplication, how to perform matrix multiplication, that also we have understood. And yeah, what is the question? Okay. Our question is, what is associative and distributive? So where did you see that? Okay, so there are some properties. Okay, I'll just explain. She asked, Swarna, since she wants to take deep dive. So there is something associative property. School time we studied in maths, right? Let's say we have something like, I'm going to say, okay, in this case, the associative property is something like this. For example, A cross B cross C is equivalent to A cross B cross C, right? This is called your associative. So if you do this way, let's say you have 3 matrix A, B, C, and if you multiply the A and B matrix, and then the result of this one, if you multiply this one, that is equivalent to this one. That is what it tells us. Okay, this is what you called your the associativity. Okay, so not yeah, we have another function called dot function. You are correct, right? So instead of multiplying the matrix, 2 different matrix directly, we can use the np dot function also. The np dot function is also doing the same thing. Okay, the what is that? It is doing the matrix multiplication. Okay. To start with, we will get into the action. I'm going to create an array now. B is equivalent to the same thing. I'm going to use it np dot array. Here I just say some value. We'll use some small value so that it'll be easier for us to compare. 1, comma, let's say, yeah, 3 is fine. And I'm going to use np dot array. So we have 3 arrays, fine. Now I'm going to call this as the associative left. Okay, this is your associative property. As per that associative property in mathematics, A cross B, the output of this one, when you multiply with this another matrix, which is equivalent to the B cross C, the multiplication of this one, if you multiply with this one, it will be same. This is what is associative. So what I do is to start with that, we will check associative. Yeah, the distributive, I'll come back. Wait. Associative. Listen, I'm going to say associative left is equivalent to we have dot function is available, np dot function, using which also you can do the matrix multiplication. So here A cross B is nothing but matrix multiplication. Okay, np dot of A comma B comma C and associative of right, np dot and np dot of, I'll tell you why we need to, sorry, in np dot of, okay, the A, right? You need to do this one, np dot of B comma C, right? So here it is wrong here. The small c, it should be capital C. Everything is capital. So np dot matrix multiplication of A comma B. And again, the output of this one, you need to take it. And again, you need to do the matrix multiplication with this one. Simply, you cannot take this one and directly you cannot multiply, right? So in A cross B is nothing at matrix multiplication. The output of this matrix multiplication value, so you need to again you need to take a matrix multiplication of this value. That is what it tells us. Now we will compare both of them. Print associative left, comma associative right. So in this case, 12, 10, 24, 22. Look here, the second one, associative right is, I'll just put here the associative. Both of them are same, the output. So it tells us very clearly, these are same, right? Associative left and right. I think this one is F string. You need to, in the printing itself, you have different format. Okay, the F string, instead of that, I just use it. No, it is not substituting it directly. Okay, and sorry, here you need to use this one, comma, yes. Associative left, it is not getting substituted here. And for that, I think you need to use string. Okay, string empty. Okay, fine. Okay, this one we'll see it later, the format, print format notation. Okay, the associative left is 12, 10, 24, 22. Okay, the second one is 12, 10, 24. So both of them are same. So this demonstrates the associative property. A cross B, the matrix multiplication of these two, or the result of the matrix multiplication A cross B with the matrix multiplication of C is same as this one. That is what we have seen it. Yes, Swarna. Swarna's question is, okay, the next one is, what is distributive property? Okay, so distributive property is something like A cross B plus C. Okay, I'll just show you that one also. So these are all high school thing. Distributive property, and here if you see, the rule is, the first rule is A cross B plus C. And the second thing is A cross B, sorry, to A cross B plus A cross C. Yes, we have something else is called commutative. Commutative. I'll just put it here. Commutative. This is a very important thing. And I guess the Java guys C++, right? You must be knowing it. So the first one is A cross B, B cross C. These two are not same. Okay, the result will not be same here. Okay, hence it is called not commutative. Okay, not commutative. So 1 second, I just. not equal to B cross A. The output of the matrix multiplication of A cross B is not same as B cross. That is what your commutative property. Distributive properties a little bit different. One second, I'll just show you that one also. And the distributive left, the same thing. We are going to use left, distributive left. My keyboard is not working. The new keyboard. NP dot and here B cross C, right? We need to use for example, A comma. We can directly do this way, right? B plus C. A comma, sorry, NP dot A comma B plus NP dot A comma C. So NP dot of sorry, yeah, I made A comma B plus C, right? A comma B plus C. For this, we need to do it. NP dot A plus. Okay, here it is not required. NP dot A comma B plus C directly. So add these two matrices and then you take the this one. So B plus C, you add it and then you do the matrix multiplication of these two. Okay. And the next one is the A comma B. So if whenever you see multiplication, it's a matrix multiplication. For matrix multiplication, obviously NP dot is used. You can use directly, right? Yeah, A star B, you can use it. But this is the one popularly used one, NP dot function. We use it in Python to perform matrix multiplication. Okay, so we can do A star B. That is also doing the matrix multiplication. But when the user, somebody sees, is this A star B is element wise multiplication, that confusion will come, or matrix multiplication. So better you can use this function NP dot. This is the one will be used conventionally. Next one is we are going to print the output of this one. Print distributive distr left, comma distributive right. So 8, 9, 18, 19, 8, 9, 18, 19. Super. A cross B plus C. And that one is equivalent to A cross B. So the A cross B and A cross C here. Okay, sorry. Here I did not put A cross C. Okay. So the matrix multiplication of these two plus the matrix of these two is equivalent to, this is for distributive property. This is your commutative property. If you multiply A cross B, okay, and for example, let's know A is equivalent to NP dot A comma B. Obviously, this will not be same, isn't it? B is equal to NP dot. Yes, you are correct, Swarna. Okay, B comma A. Print A comma B. So here 4, 6, 10, 12, but here 2, 4, 10, 14. So commutative in the sense A cross B is not equal to B cross A. The distributive is A cross B plus C is equal to A cross B plus A cross C. And whereas associative property tells us A cross B cross C is equivalent to A cross B cross C. So these are same. This is the rule. You should be knowing it. Associative rule, distributive property, and commutative. So I think MCA, they teach all the things. Okay, and what is the other questions? Can I... okay, your question is a little bit different. One second. What is the question? So can you type it one more time? Oh. The diagonal value, right? Okay. You want to display only the diagonal value for matrix A, right? Is that what your question? Swarna, is that what your question? She wants to display only the, okay, so we have some diag function, okay? For example, np dot diag, how to display the diagonal, how to display only the diagonal values. For example, in our case, the matrix is 4, 6, 10, 12. You want to display only 4, 12, right? So this is a diagonal. 4, 12 is the diagonal, right? Diagonal values. You can put a dot diag, a dot, sorry, not np dot diag. There's something called np dot diag. Inside the parenthesis, you need to give a. Look here, it gives you only the diagonal values. Got it? This is how you can take only the diagonal values. So there is a diag function is available. What is the next question? Okay, how to replace the diagonal values only? I attended one interview. They were asking this question. Yes, that is also possible. Okay. You want to replace 4, 12 by what values? You tell me some. See, there is something called fill underscore diagonal. There is something called fill underscore diagonal. Okay. With that, you can do it. Whatever value you want, you can. So, for example, np dot fill underscore diagonal, diagonal, right? So, diagonal. And here your matrix A, small a, comma, you have 4, 12 were there in the, so what I'll do is I'll just replace the 1, 1. Okay. And I just, let me see, even I forgot this one, np dot fill diagonal. And your matrix name 1, 1. And here, how do we view, why it's not showing the output? Okay, now you need to print A directly. So now you print A. Look here, 1, 1. The diagonal values 4, 12 were replaced by 1, 1. Using fill diagonal, you can replace the values of diagonal. So look here, these are the interview questions. This is really helpful. Okay, and you can face any interviews confidently with this kind of things. Okay, and the fill diagonal, obviously, first argument you need to specify which matrix you want to replace the diagonal value. For that, you need to tell explicitly the matrix name first. Okay, fine. How do I multiply the values of yeah, so in that case, what you do is how do I multiply the values of diagonal, right? So np diag A, I think you want to do multiply with some value 2. Sorry, in this case, yeah, 2, right? Correct. So you take the np diag A. So for this matrix, the diagonal values are 1, 1. You can directly multiply 2. So 2 into 2, right? You can do it this way. Or if you want to multiply the diagonal values with different values, for example, this one you want to multiply by 2, this one you want to multiply by something else, then you need to access the values, separately. Okay. Okay, how to, is it possible? Array is iterable. Okay, so, okay, why do you want to know this one? Yeah, you can use for loop here, right? You can use for loop. For example, you want to fetch each and every value for row in A, and for let's V in row, print row, something like that. Okay, so 1, 6 and 1, 6. Okay, here, so okay, this is not required. But remember one thing in Python, you need to see when you use a for loop or if you use any control structure, right? You need to specify a tab. You need to press tab. Okay. Indentation should be. This is called indentation. The tab is nothing but if you press your space bar 4 times in your keyboard, that is equivalent to your tab. Either you can press the tab 4 times or simply press the tab key which is in your keyboard once. Okay. So that see if you type it first let us execute. So 1, 6. If you want to access it row by row, you can do it this way also, right? So 1, 6 is the first row and second row is this one. Okay, that is how you can access it. Row by row, yes, you can iterate the values of a matrix also. That is what I'm trying to say here. Okay, how do I flatten an array or matrix? What do you mean by flatten? Okay, for example, our question is, this is a matrix. I want to flatten this a one-dimensional array. A dot flatten. You have something called flatten function. And if you do it, look here, 1, 6, 10, 11. This is how you can flatten the values. Okay, you don't want the value to be stored in array. Instead, you want it to be displayed as a one dimensional array. You want to convert the matrix into one dimensional array. That is also possible using flatten function. So I think I have covered almost all the scenarios as part of matrix. And also we discussed about the distributive law, associative law, and commutative law. And we discussed about the difference between array and matrix. Array is multidimensional, whereas matrix is two-dimensional. Okay. And also we discussed about the functions like ndim, shape, size. Shape gives you the number of elements in your array or matrix. And size gives you the number of rows and columns in your matrix or array. And ndim gives you the dimension, whether it is a two-dimensional array, three-dimensional array, four-dimensional array. Okay, that is what you can understand with the ndim function. So that is pretty much about this one. Okay, fine. The next one is next topic is the conditional programming. Yeah, since many of them did not join, right? We'll carry forward this on this Saturday and Sunday. Okay, so this Saturday and Sunday onwards, it will be streamlined. There will not be any more changes. Okay, because I'm traveling. Even in USA, I'm traveling one place to another place, one location to another location of the offices. Right, the laptop issues, other things are there. Okay, so what we'll do is we will continue the rest